Hello class, today what we're going to be doing is going over the scaled picture program for the test. So you should know what a pre is. So in this class, a pre is what you knew before. This is actually what you knew, it's not what you did not know. The post is what you learned through the program. This is not the requirements for the program, this is what you actually learned when you were doing the program. It can be programming wise or it can be how Mr. Fenson's amazing. I did not pay this student to write this. The next one is the summary is what the program does. So what I mean by that is when I compile this and run applet and hit OK, whatever shows up on the screen, I need to describe this in English, not in programming English, just in English, what the program does. That's what the summary is. The other interesting thing about here is when I click run applet, these two numbers pop up. These two numbers mean when I press OK, this is the default applet, 500 by 500. That means if something's over 500 by 500, like all this space over here, you cannot see it in the default applet. So when I open this up, we have these import statements. You do not need to know these. You do need to know this line right here. Public class program name extends applet. Extends applet is easy to remember because you right-click run applet. The public class should be easy to remember because you're in a public school with a public class and you're a public student on a public chair. Anyways, you also need to know this naming convention. It is always last name, first letter of first name, and period. And then whatever else. This is what's called a function call. What it does is it calls a function with certain parameters. You don't need to know parameters, but you do need to know what they do. So these parameters basically say, I want to call the function ihome with these values. So parameters are just basically values passed into a function. But these values become x, y, width, length right here. So you should know if I go like this, I'm not going to see the picture because this is way off the screen. If I compile and run this, and I'm going to comment these all out so it doesn't confuse you. You see how even if I expand this all the way, I can't see it. The only way I can expand is if I bring it all the way over, and then even still going like that, I still cannot see the image because it's way past, it's almost like probably right here is where it's at. What you also need to know, if I do this, where I go 200, 200, 0, 0, will that compile with a double zero? Yes, it will. I would say this is a logic error because logically this doesn't make sense. This is definitely a logic error. Why is this a logic error? So the next thing is what we have here is when we have a function call, we have several values that we could put here. Ones that we have to be aware about are that if we put 0, 0 here, 0, 0 is technically just 0, so it's the same thing. But when we compile and run this, if we look at this code, we actually think that nothing will show up because the width and length is 0. However, if we look at this closely, what we have here is, if you look really, really closely right there, see that little red dot right there? That red dot is this pixel, this image right here. Because what happens is we start drawing here, and even though it's 0, 0, we still get one line. I personally do not know exactly why this happens. I just know that I think it's because we're drawing something, it draws something, and that's pretty much it because there is a function call. It starts drawing, it doesn't know that it's 0, 0 length. So it just works. It might be because of the lines. Actually, let's check that. If we have just the lines, we comment out all the lines and we only have rectangles and ovals. The question is, do we get something to draw? Because if it's lines, it makes perfect sense. No, it still happens. So even with rectangles and ovals, we still get a dot, even though, yeah, we only have rectangles and ovals. So rectangles and ovals happen, and lines definitely happen. I know that. So even though it says 0, 0, it still shows up on the screen. If I put in a decimal, will that compile? No, even if it's 0, because it's saying down here possible lossy conversion from double to int. Double means with a decimal, D decimal. Int means just a number. So if it has a decimal, you can't compile. That's a compile error. Logic error is your brain. Compile is computer. C-O-M, C-O-M. So will we be able to see this image? Let's take a look. Nope. So then the next question is, will I be able to see this image? 100 width, 0 length? No. Ooh, yes we can. That means we might be able to see the 10-0. That is very interesting. Now please realize you should have been, let's see this. We should be able to see this. Yep, see it? See the little green dot right there? Right there, everyone see it? So that means if I have even one value in my width or length, you can see it. Because it basically just becomes a line. And there it is again. When you do something like this, is this a logic error? 1010. Well, let's see if it is. So if I print screen this, and I maximize this, does that look like my image? I would actually probably call that a logic error, because you are drawing the image too small for it to work. Yeah, I would call that a logic error. Because think about it, how many pixels does this require? Probably at least 20. The easy way to see what the requirement is if it's less than this number right here, it probably won't work. Now his will actually work for 15. If I go 15, 13, it'll probably work. So let's just try that. Because that means everything will have at least 1 pixel. And that does look like it's good. Yeah. The windows are 1 pixel. But does everyone see the difference between this and the 10 one? So if I undo, that won't undo. So let's take a look at the comparison between this and the comparison just between 1010. Please realize when you were coding this, this is the kind of stuff you should have been doing between steps, is playing with these numbers to see what happens. Because if you didn't, I'll show you what's going to happen in 2 seconds. Yeah. So see the difference between the door and the windows? There's a significant difference. And of course, the bigger you get, the better the image quality. So I would even say probably if you did anything less than 50. If you did 50, I think that would be a good... Yeah. Does everyone see the difference there? How this actually looks like the image. And even this one still doesn't. It does. Actually, no, it does, I would say. That does look like that image. Does everyone see that? You have the door. You have the plus sign windows. You have that side thing over there. And you have the roof. What feature is over here that you can't see over here? Does everyone see that? It looks like crap, but it has every feature. Except, I think it doesn't have the... Actually, it does. It has those background windows right there. These windows right here. See how it's blue around the teal? There is blue around this teal because this rectangle is a draw rect. So that means it doesn't fill on the inside. So these 4 square pixels right here are actually 8 pixels with the middle empty with the teal drawn over it. You're just seeing the teal on. So basically what's happening is, and this is also vitally important to know, is when he does his program, he draws blue then teal. So what's happening is he is drawing his rectangle with blue. And let me steal that color. So he draws the blue rectangle. And he draws it pretty small. And then what happens is he draws the teal lines on top of it. And then see how you only get the 1, 2, 3, 4 blue pixels, and you have the 5 red pixels, because 5 teal pixels, because the teal pixels draw over the blue pixels. What that means is, if I go into the code, and you should know this, if I go g.draw rect, fill rect, x, y, width, length. Is that a logic error? If the last line of a code is a g.fillRect, is that a logic error? Yes, it is. Reason being is because, look, what do you see? Do you see the image? No. Do you want to see the image? Yes. Does everyone see that? The other one is if you do this, x times y, that's a logic error. Because your program will not work the way you want it to. And that's probably huge. I didn't think about that for a second. So that right there is a logic error, because I don't want that to happen. My brain messed up when I was coding, basically. A compile error. Let's go through the compile errors real quick. Oh, wait. There is already on box. If you go to box and you type in stud, oops. And go to scaled picture and common programming errors. All of these errors, do you think they're going to be on the test? Yeah, so let's go over them. Rect, oval, and line has to be uppercase. Draw and fill is lowercase. G is lowercase. It's a period. You can't have a fill line. It needs to be x plus width times the number divided by the length. Y plus length times number divided by length. Please realize this number and this number have to be smaller than whatever you divide by. You can't have an x plus y plus on a rect or oval. You need it on a line. And you need a semicolon at the end. These are curved brackets. It's a plus sign, not a multiplication sign. It's a multiplication sign, not a plus sign. It's a division sign, not a multiplication sign. All those things you should know. You should know this line of code. No doubt about it. Back of your hand. Let's take a look at some other programming errors. If I did color.B, compile error. If I did lowercase b, no semicolon, compile error. This is a compile error. This is a compile error. If I do draw color, that's definitely a compile error. If I've changed G to even an uppercase G, if I change it to draw, if I change it to anything other than G pretty much, I have a compile error. Please realize that if I put my blue and I don't have my blue declared like Kanye West is, I'll have a compile error. Please realize that. Is this a compile error? Color.purple. Compile. Purple does not exist. If you go to your box account, the ones that you're required to know are the ones that I gave you. So click on tutorial. If it's not, let's see if I can get the right one. Yes. If it's not yellow, green, orange, magenta, black, blue, or red, I'm not going to test it on you. Because these are enough to know. The other one is, how big is this number? 255. That means if it's 256, this is going to be a compile error. Well, let's take a look. 256. Compile. So we're going to go into edit colors. And yeah, that should be white. Okay. So that means if I make this 270, what's going to happen? Is the line still white? No, it becomes black. Does everyone see that? So that's actually a logic error. I'm sorry. I always thought it was a compile error. I didn't think about that. So what that means is if you put in a number greater than 250, so if I put in 255, this should be white. I should have a white roof. There's the white roof. If I put in 256, it probably breaks and sets the default value to 250 to black. Yep. So it would be a logic error, not a compile error. Because I want white, but it gives me black because I'm out of range on the 255. This right here can be any name. Technically, he should have done this, K, because it's not an object. Technically it's an object, but it should be, the naming convention is lowercase, but I'm not going to test you on that. You should know this line of code though, and this should be something, so like my color. So color anything equals new color parenthesis with commas, 3 values, not 2, not 4, but 3, parenthesis semicolon. You don't need to know what happens here. I'm not going to test you on that. You should know that this compiles. You should know that this compiles. You should know that this compiles. You should know that this does not compile. You should know that this does not make sense. You should know that this does not make sense. You should know that this does not make sense. Logic error. Does everyone see that? Any questions on that? The next one is, you should be able to, if you go to Google, and if you type in Mega Man, and go images, if I take this right here, I should be able to draw this image. And you should be able to draw this image. What I mean by that is, if you take Mega Man, and I'm going to draw everything I want to draw in circles, you should be able to give me this value. You should be able to give me this value. You should be able to give me this value. You should be able to give me this value. You should be able to give me this value. You should be able to give me this value. You should be able to give me this value, this value, this value, this value, this value, and even the line, this, and then 1, 2, 3. You should give me be able to give me the XY width length without the use of a computer. Does everyone hear that? So you can't just go like this and read the bottom left and then use the select tool to give me the width length. You should be able to have a graph on here, and you should be able to graph this yourself, by the way. If I'm not, probably not even going to give you graph paper. You should be able to go like this and say, well, this is my XY width length. This is my width and length. And then you should be able to go like this. And basically pixelize the photo. So now you should be able to give me all the XY width lengths. To do that, what you need to see is, so let me do the next one down. So real quick, what I did was I made a XY width length coordinate. So coordinate system here. So now I can say, okay, well, let's go this object right here, object number 1, the circle. It is 0, 1, 2, 3, 4. You should know that it starts at 0, by the way. So this circle starts out basically It's 3, 0, 1, 2, 3, 4, and then 1, 2, 3, 4 and a half. So 4.5. You can give decimals in your pseudocode when you pull this, because you could just do 30, 0, 40, 45. So I'll allow decimals just to make your life easy, because once you put it into code, it'll be different. Actually, no. Let's not do that. So you can't do decimals. So you either have to multiply by 10 or round to just 4 or 5. You cannot give decimals in your code, because I'm going to be asking you to put it into actual code. So that wouldn't make sense. So object number 2, 2 would be 4, comma 2, comma 1, 2, 3, comma 2. Does everyone see how I got those numbers? The lines, to get a line, you give me a point. Give me a point. Gives me the line, x, y, x, y. So this would be 5, 6, 7, 8, 9, 10, 11, so 12, 1, 2, 3, 4, 13, 4 would be this line right here. You should be able to pull coordinates from a picture. You should also be able to pull them and take the complete test. This should not take you very long to do. If this takes you a while to do, you need to practice, and I will give you guys stuff to practice with. The next one you should be able to do is if I give you code. There we go. If I give you this code right here, you should be able to draw it without a doubt. You should know how to draw a rectangle, oval, and line just from values. And you should be able to draw it. Just like on the practice test. Hope that doesn't. There we go. So just like on the practice test, you should be able to give me from objects, give me code. From code, give me objects. You should be able to do it by hand. I'd recommend bringing in colored writing utensils for the test, because you're going to have multiple colors. Also, you should know when you draw this circle and this circle, you can't see most of this circle. You should understand that. You should understand that they both don't show up. There's definitely going to be a compile error section to the test. There's definitely going to be a logic error section to the test. There's going to be a visible section to the test. And there's also going to be some other true-false questions. That's pretty much it. I think I covered everything. What does this line of code do? It's actually a really good question. So, what we have here is a formula. And please realize the values that we get from here. Let's just do this. So 20, 30, 40, 50. So we have this really, really long formula. And what we want to do is we want to make it so that every time I change this x value to 50, this whole formula changes. But if I had it like this, I would have to go in and change this value to, if I change it from 20 to 50, I would have to add 30, add 30, add 30, add 30, add 30, add 30, add 30 to every single x coordinate. And then for the lines, I'd also have to add 30, add 30, add 30. So instead of doing that, what we do is we create a variable. And what this variable does is it says, I want to take this value and plug it in for here. So the code sees it. Once I compile, the code sees it like this. It doesn't see it with x. It's straight up, whenever I see a variable, it just replaces that variable with the value at that line. So the next line, I do the same exact thing. But the nice thing about this is it allows me to change the value here to affect multiple lines of code instantaneously. And I can do it on the fly. So if I wanted to scale it up quickly, so if I wanted to go like, let me comment this out. If I wanted to go, you guys don't know what this is yet, but it's a for loop. If I want to take this g.fill oval code and say what I. What I'm doing is creating a random color every time I run this. That's what this does, and I'm just filling an oval. It goes from 1 1 1 1 2 2 2 2 3 3 3 3 4 4 4 5 5 5 6 6 6 6 all the way up to 100 100 100. So when I forget to put the closing bracket and compile this, oh wow, it's been a while. When I compile and run this, ooh, MathWorks. Look what happens. Does everyone see what happens real quick? What's happening is I draw a circle from 1, 1, 2, 2, 3, 3, 50, 50, 100, 100, all the way up, increasing by 1 every time. And that's why you see a random color every single time. So what this means is the only way I could do this, instead of typing out this every time and saying, the only other option I have to do this would be to take this code and go 1, 1, 1, 1. And then on the next code, when I change that value, I would have to go 2, 2, 2, 2. And go through every time and put in these values. Now realize this is a loop, so it's going to do this a lot quicker. But this makes it so that every time I run this value, these values change. By these values changing, it's the same concept as these values changing. This formula basically makes it so that your x is the starting top left. And then I'm going to add in the percentage that it starts inside my image. So take the percentage of the image, multiply it by the width of the image, and I get the add-on from, if this is my xy width length, and I want to draw this circle, this square, the distance from here to here is a percent of the whole. So if I take the percent of the whole, multiply it by the width, I get this distance right here. That distance right there is this number right there every single time. So this percent times the length is the percent of this divided by this gives me this value. Does that make sense? Great. So what you're going to learn later on is how to loop stuff. So you can then take this and make a double nested for loop. So int z equals 0, z is less than 10, z plus plus, and then I want to change my y value plus z times 10. 110, 20. 20. So now this is going to, everyone watch this real quick because I think you guys will like this. So with these 2 lines of code, actually no, these 5 lines of code right here, watch what's going to get drawn. What? Oh. And then I can do this and make a 3-dimensional one. So for int y equals 0, y is less than 10, y plus plus, and I'm going to change my x value by y plus y times, let's do 25. And then the only difference I have to do is I have to reset z, so z equals 0. Actually, it should reset anyways. Oh well. Oh, I can't do y. Duh. V, 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 V. And now I compile and run it. Oh gosh. That would be an infinite loop. So the bad thing is once you get into these loops, it's really bad. Okay, so I should not have put that in there. Oh yeah, that would have been really bad because it would have just redrawn. That should work. Let's see if it works. There we go. So I need to make that a little bit bigger. They're not. Let's go 50-50. See what happens. We can still make it a little bit bigger. Let's go 100-100. And then let's do this one thing where inside this loop, and then we can do a while true. You guys will really like this one. What's going to happen? Watch this. I'm going to break my computer, literally. It's broken. Now, please realize I just expanded the window, and it's still going on, and it's so backed up in the stack that it's probably going to take a good 10 minutes for this to expand out. So it won't know that I expanded this window for a good amount of time. So let's close it again. Now to change that so it opens up in a larger window, I just need to change this to 2000, 1000. So, yeah, now my computer's definitely broken. But anyways, by using variables, it allows me to change the value on the fly without actually changing the value because it's just set to a number. So all this is a number. The computer doesn't see it as a variable, it sees it as a number. Just like it does up here. All it sees is one number. What I should have done was, probably should have made this 10 and then doing this times 10. And this probably would have looked better. There we go. That can actually run it a lot faster. So this I'm actually keeping up with because it's not eating up as much processing power as the last one. So it's going a lot faster. Okay, that is it. Have a good one. Good luck on the test. I hope you all fail and have a great day staying after making up this test. I will see you all later.